Okay, looking at the next part. Now, when I introduced systems of linear equations, I went ahead and took a couple of examples attempting to put in what was referred to as reduced echelon form. And it was a little bit of a leap in terms of the process, and I wanted to sort of backtrack and mention some things about the categories, what separates from an echelon form, from a reduced echelon form, from that which might not be either. And we have for echelon form, okay, now we have for the first three items, a rectangular matrix is an echelon form if, first of all, all non-zero rows are above any rows of all zeros. Second, we have each leading entry of a row is in a column to the right of the leading entry of the row above it. And third, we have all entries in a column below a leading entry are zeros. Okay, now, so those will be the criteria for at least echelon form. Now, in the case of reduced echelon form, okay, you're going to have the first three characteristics, okay, that again will define an echelon form, but also you will have fourth, the leading entry in each non-zero row is 1. And we have that which caps it off is that each leading one is the only non-zero entry in its column. Okay, let's take as an example. Okay, say if you have determining if this matrix is an echelon form, reduced echelon form, or neither. Okay, so we got 3, 1, 2, 0, 4, 5. Okay, and it says all non-zero rows are above any rows of all zeros. Okay, so we don't have any rows of all zeros. All right, so at least there's no obstacle in satisfying number 1. And now we have in the second category, each leading entry of a row is in a column to the right of the leading entry of the row above it. Okay, and okay, so we have for the first row, we had the leading entry to be at 3. Okay, and this is going to be above this particular 0. And then we have with the second row, leading entry is going to be at 4. So we have at least this particular part is satisfied. And we have third, all entries in a column below a leading entry are zeros. Okay, so at least in this particular part, okay, for what we have concerned, okay, this 3 is above that 0. And so that particular part is satisfied. Okay, and now for what we have here, we have echelon form, but to see if we have reduced echelon form, okay, it says here the leading entry in each non-zero row is 1. Now the leading entry here is going to be at 3. And for what we have here, you had the leading entry in the second row is equal to 4. So this added condition, okay, is not satisfied. And if the fourth condition is not satisfied, the fifth one will not be either. So we have in this particular case, okay, this is going to be echelon only. Okay, let's say if we have with these two matrices, just to see if we have echelon or reduced echelon form or neither. Okay, so we have with this second matrix, so we have 3, 0, 0, 5, 0, 0, 4, 7, and 0, 1, 5, 9. Okay, and we have here all non-zero rows are above any rows of all zeros. Okay, so we don't have any rows of all zeros, so that part is satisfied. Now we have with the second matrix, it says each leading entry of a row is in a column to the right of the leading entry of the row above it. Okay, and if you notice, okay, so if we start out with 3, and it got 4, okay, and we're looking at progressing. Okay, notice, okay, if we were to maintain, okay, like a bit of a staircase, now the next non-zero entry should be where the 9 would be located. But if you notice, you have 1 all the way back here. So this part is not satisfied. So we have, for this second matrix, okay, this will fall in the neither category. And just resetting, okay, now we have, if you notice, we have by and large, okay, had the same elements, say for x1, x2, x3, but I interchanged, okay, the second and the third rows. Okay, so going back to see if we have either category, echelon or reduced echelon form to be satisfied. Okay, so we have, first of all, okay, we don't have any all zero rows. So first part is satisfied. Each leading entry of a row, okay, so leading entry here is going to be 3. Second row have leading entry is going to be 1. Last you have the leading entry is going to be 4. And so, okay, so you're going to have, so each one you have, each leading entry of a row is in a column to the right of the leading entry of the row above it. Okay, so you have 1 is to the right of 3, 4 is to the right of 1. So this particular part is satisfied. And we have all entries in a column below a leading entry are zeros. Okay, so you got 3, 0, 0, and you got 1, 0. And since 4 is in the last row, there's no burden for there to be zeros underneath this. Okay, so this particular part is satisfied. And we have fourth, you had the leading entry in each non-zero row is going to be 1. So you have fourth and fifth cases will strike out. So we have, for this particular part, okay, this is going to be echelon form. Okay, now looking to see if we have matrices 4 and 5 to be either form or neither. And we have with matrix 4, okay, we don't have any all zero rows, okay, and then we have second case, you have each leading entry of a row is in a column to the right of the leading entry of the row above it. Well, guess what? We have a leading entry of the first row, okay, we have it 1, but guess what? We have we don't have any leading entry for the second and the leading entry, okay, that would be 1. So you have an imbalance here, so second case already strikes out. So for this particular matrix, okay, this is going to fall in the neither category. Now testing out what we have in the fifth matrix. Okay, so I still have the same elements. However, I interchanged, okay, some of the rows here. And in fact, I went from third to first, and went from first to second, and from second to last. Okay, and to see if we have at least an echelon form. Okay, so we have, again, we don't have all zeros, so that part is satisfied. And we have each leading entry. Okay, so you have, first row we have leading entry is 1, second row leading entry is 1. Okay, so, and again, so you have each leading entry is going to be to the right of the leading entry of the row above it. Okay, so far so good. Again, you don't have any 1s to the left in the next row with respect to the position of any 1 or non-zero entry of what was in the row above. Okay, and then we have all entries in a column below a leading entry are zeros. So that part is satisfied. Okay, and okay, so third condition is met, and then we have fourth, the leading entry in each non-zero row is going to be at 1. Okay, so leading entry, okay, so that is satisfied, and that is satisfied. So this condition is met, and then each leading one is the only non-zero entry in its column. So just for the last bit, okay, so we have this one only exists, and this one only exists, okay, and there was no 1 here. Okay, so So that is satisfied. So this is going to be not just echelon form, but reduced echelon form.